Okay, example 11.8 from the text. A tire manufacturer advertises that its brand of radial tires has a mean life of 40,000 miles with a population standard deviation of 1,500 miles. Okay, so the first thing that you're provided with is a population mean, mu, and a population standard deviation, sigma. A consumer's research team decides to investigate this claim after receiving several complaints from people who believe the mean life of 40,000 is too high. If the research team tests 100 of these radial tires and obtains a sample mean tire life of 39,750, is the advertisement legitimate? Use an alpha of 5%. When you read a hypothesis test problem from this section, 11.3, there are 6 things you need to highlight out of the text of the problem. The first thing you're reading for is mu. So in here, mu is 40,000. The next thing you're going to read for is sigma, which is 1,500. The next thing that you're reading for are the words that indicate the direction of the alternative hypotheses. The alternative hypothesis. In this case, the counterclaim is that the mean life of 40,000 is too high. So if 40,000 is too high, the counterclaim is that the population mean should really be less than 40,000. And so this in red here gives us an indication of the direction of our test. So far the 3 things are mu, sigma, direction, which coincidentally is going to be on the left. N, size of the sample, is the 4th thing you're going to read for. The 5th thing is the value for x bar. In this case, the value for x bar is 39,750. Now, even though the words of the problem don't say x bar, we know that the sample mean is symbolized with an x bar. And the last thing you're going to read for is the value of alpha. So every one of those 6 items needs to be provided to you in some way in the problem. We are trying to show that we are going to try to prove the counterclaim that 40,000 is too high. So we're going to get started with this process by first coming up with the null and alternative hypotheses. The null hypothesis is always also the alternative hypothesis is always going to begin with the words the population mean in this section 11.3. So HO is going to be the population mean tire life is 40,000. This is the claim about the population. This is the established status quo. And then symbolically, we're going to state mu equals 40,000 miles. What we are trying to show in this hypothesis test, we are trying to prove that 40,000 is too high. So the alternative hypothesis, which is the counterclaim, is that the population mean tire life is less than 40,000. Okay, because we always want our alternative hypothesis to either use the phrase is less than or is greater than. And there's a reason for that, and we'll see it as we move towards the next step of the process here. But it would be incorrect for you to state 40,000 is too high right here. We want to stick with the phrasing is less than or is greater than. And then symbolically we have mu less than 40,000. So this gives us an idea of where our test is headed. The center of the distribution is going to have 40,000, and we want to show through sample data that the sample mean is significantly less than 40,000. If it's significantly less than 40,000, we have enough evidence to state that HO, the mean at 40,000 is not correct. The mean of the sampling distribution and its correct symbol. Our sampling distribution is a collection of sample means, and so the mean of all the sample means is denoted by mu sub x bar. And its value in this problem, the same as the value of the population mean, is 40,000. So our test is based off of the sampling distribution of sample means, and in the very center we have 40,000. And so therefore we can answer the following question: is it going to be based on the normal distribution or the t-distribution, and why? Well, it's going to be based on the normal distribution because we have a sample size n that's greater than 30 and the population standard deviation is given to us. Those two criteria are required for you to state that you're using the normal distribution. Most importantly, in this chapter, we're going to keep an eye out for the population standard deviation being provided to us, because the moment it's not given to us, we're going to use the t-distribution. So we're going to be using the normal distribution in every example in this lecture. The next lecture, we're going to be using the t-distribution. Today, it's all about the normal distribution. The decision rule is basically going to guide us in how we make our decision. Here's a model of what you can draw for a test involving the words less than. In the alternative hypothesis, remember that we stated that the population mean is less than 40,000. The fact that we're using the word less than gives us a hint as to the direction, and basically it means in this case that our test is on the left side of the bell curve, and we should be shading in an alpha of 5% on the left side of the bell curve. In the very center of our bell curve, we have a mean, population mean of 40,000, which is the same as the mean of the sampling distribution. Our sample mean is going to be falling somewhere on the left side of center. We want it to be far away from center, because the further away it is from center, the more reason we have to reject the null hypothesis that stated that the mean was 40,000. Okay, so we want our sample mean to be far away as possible, and notice what happens as we push our sample mean further and further to the left. So remember that the sampling distribution is a collection of possible sample means, and along the horizontal axis, the sample mean can be positioned. If the sample mean is positioned far away to the left, the p-value of that x bar, which is basically the area all the way down to negative infinity, the p-value becomes very small the further x bar is positioned away from the center. If you position x bar close to the center, the p-value, which is essentially, again, the area all the way down to negative infinity from that point, is large. We want to create a small p-value. A smaller p-value, a p-value that is smaller than alpha, will give us sufficient reason to reject the null hypothesis. Reject the 40,000. If we have a p-value that's larger than alpha, which means that the sample mean is going to be positioned somewhere over here, then the conclusion is going to be to fail to reject the null hypothesis. So we can't reject the 40,000. So we're going to formulate our decision rule as follows. Reject HO at alpha equal 5% if the p-value of the sample statistic is less than or equal to 0.05. We want the p-value to be smaller than alpha, because if it is smaller than 0.05, if it is, it would indicate that x bar is positioned somewhere in this shaded region. And somewhere in this shaded region is considered far enough away from the center for us to reject the null hypothesis. Okay, so our decision rule is always going to be stated in this format. We're going to start with reject HO at, and then we're going to provide the alpha that was given to us in the problem. If the p-value of the sample statistic is, and then we're going to state less than or equal to 0.05 or less than or equal to 0.01. We're going to now look at our sample data. So going back to the words of the problem, the sample statistic in this question is an X bar. In fact, every sample statistic that we do in this lecture is going to be X bar, the sample mean, because our sample mean is the thing that we're testing against the population mean. Its value is 39,750. Okay, so noting those two things, those are part of the sample. Our next step is to locate where this sample statistic lies on the bell curve. So if we look at the normal distribution, the bell curve, and we note that the center is 40,000, 39,750 is our value for X bar, and it's somewhere on the left side of 40,000. When we calculate its p-value, we will be calculating all of the area from negative infinity up to 39,750. When the test is on the left side of the bell curve, so those are tests that use the words less than in the alternative hypothesis. When the test is on the left side of the bell curve, the p-value represents the area that goes down to negative infinity. And when the test is on the right side of the bell curve, which we're going to see in the next example, the p-value is going to be the area from the sample statistic up to positive infinity. So this is a test on the left. The p-value that we calculate will be the p-value from negative infinity up until 39,750. So the next step is to figure out what that p-value is. Now, in the last lecture, we were able to do that using normal CDF, because normal CDF will use the normal distribution and find an area from negative infinity to a particular point. Now, we call that area a p-value, a probability value. What we're going to do this lecture is do something a little different on the calculator. It actually makes the process a lot easier. We're going to be using a function on the calculator called ZTest. We're going to press stat, tests, and then ZTest. So it's on your calculator. It's in the same location as the confidence intervals. It's number 1, ZTest. At the top, you have an option of pressing data or stats. If you don't have the raw data, which we don't, we're going to go over to stats and hit enter. Mu sub 0 is the population mean, the population that was put forth in the null hypothesis. So that is 40,000. Sigma is the population standard deviation. Was it 1,500? X bar, 39,750. Sample size is 100. Okay, so these four values come right from the words of the problem. The next line, mu colon not equal to mu sub 0, less than mu sub 0, greater than mu sub 0. This indicates the direction of the test. In this class, we're not going to be using a not equal to test. That would indicate that both tails get shaded. So we don't have that scenario, although you will see it in the textbook if you take a look at the textbook. We're going to either have a less than test or a greater than test, a test on the left or a test on the right. Now, our alternative hypothesis used the phrase less than 40,000 miles, and that's why we are going to use the less than mu sub 0 test. Oops, didn't mean to do that. Now, I had said before, there's a reason why we want to make sure our alternative hypothesis uses the phrase less than or greater than. And it's exactly for this reason. Using the words less than or greater than makes it clear at this point which direction to choose. It also makes it clear when you're drawing your picture what side your shaded area should be on. So after you've got the direction set, you go down to calculate and you hit enter, and you get a few things, some of which are going to be important to us and others not. The first is not so important, but it is nice to note. The z-score for the sample statistic, the z-score for 39,750 is negative 1.67, which indicates that x-bar, 39,750, is on the left side of center. If its z-score is negative, it's on the left. The next line is the p-value. That's what we're after right now. We're going to round our p-value to 4 decimal places because that's what we round probabilities to in this class. So we have 0.0478 as the p-value, and the next 2 lines just give us a reiteration of what x-bar and n were. So this p-value, 0.0478, gives us a probability value, which is essentially an area that goes from negative infinity up to 39,750, 0.0478. So if we look at a picture now, the p-value is this area. I know this is kind of crude looking, but in orange, everything from negative infinity up until 39,750 is considered the p-value, and that it came out to be 0.0478. Everything in blue is considered alpha. Now, if you compare the values for the p-value and alpha, you should note that the p-value is smaller than alpha. So in terms of area, the p-value, the orange part, is smaller, fits inside the blue value for alpha. So the p-value orange is smaller than alpha in blue, and so the p-value is considered, the p-value fits inside alpha, and therefore our sample statistic, 39,750, is considered significant. If it were larger than 5%, if the p-value happened to be greater than 5%, then we would see that the orange piece overshadowed the 5% alpha piece, and we would come to the conclusion that it was not significant. Okay, that the sample statistic was not significant. But being that it's smaller than alpha, we say that it is significant. When we get a p-value that's somewhere between 1% and 5%, we say the result is significant. When we get a p-value that's smaller than 1%, we say the result is very significant. When we get a p-value that's greater than 5%, we say it's not significant. So this is how we state our conclusion. There are 2 conclusions in a hypothesis test that are possible. Either you're going to reject the null hypothesis and accept the alternative hypothesis, or you're going to fail to reject the null hypothesis. This problem, because our p-value was smaller than alpha, we are going to reject the null hypothesis and accept the alternative hypothesis. So our conclusion should be stated as: we reject HO and accept HA at alpha equal 5%. In general, we're looking for a p-value that's less than alpha, and if we get that, we are going to reject the null hypothesis and accept the alternative hypothesis. The last part of the question involves going back to the original question and answering it. So if we go back to the original question, it was, is the advertisement claim that the mean life of a brand of radial tires is 40,000 miles legitimate? Is the advertisement legitimate? So this is what trips many students up, because while they can conduct the hypothesis test and compare alpha and the p-value without problem, it's hard to interpret what it really means in the scheme of things. In this case, the advertisement is not legitimate, and here's your explanation. When you reject the null hypothesis, you reject that the population parameter is 40,000. So remember, our population mean in the very beginning of the problem was stated to be 40,000. We wrote that in our null hypothesis, that the mean is 40,000. But we rejected the null hypothesis. So when we reject the null hypothesis, we reject the 40,000. The tire manufacturer advertised that the mean was 40,000. Our hypothesis test has shown that it's incorrect. So the advertisement is therefore not legitimate. Sometimes you've got to do a little bit of thinking with this last question to realize what the answer is. But if you go back to the original question and the way it's phrased, you'll probably figure this out. So that is a complete hypothesis test, going through all the steps from the null and alternative hypotheses down to the conclusion and final question. So we have a couple more examples just like that, and after a couple of tries you easily get the hang of the process.